apologize for the delay. I need to be wired up. Okay, I'm supposed to chair this session, but I'm also the speaker. So I've been told to introduce myself. I think there are many people in the audience who already know me. I should not be so presumptuous and to say that I need no introduction, so I'll still introduce myself. That's my name, and I joined the National Institute of Education about more than 10 years ago. And before that, I used to teach at a junior college in Singapore for a few years, and then I went on to do my PhD in the area of computational modeling or mathematical modeling, in particular with applications to biological systems. And currently, what I'm interested in doing in terms of research is in computational modeling, computational methods in partial differential equations, as well as applications of those methods in looking at how certain physical situations, especially biological systems, can be modeled. For today, I'm going to speak on problem solving and mathematical modeling. And my objective is to make sure that I finish the talk on time, or even before time. Not so much because the program after this is lunch, but more because I believe in talk less, hear more. Okay, this is the outline of what I'm going to talk about. I'll start with a brief introduction, or what I believe is mathematical modeling, and then maybe some approaches to mathematical modeling. And then we'll look at some examples. Now, I'll be touching on a few fairly simple examples, but there'll be one that I will go into detail, mainly because I realize that hopefully in this room, most of you are dealing with junior college students, so you will be more familiar with the curriculum for H2 and maybe H3 mathematics. So I'll go more into detail for one of the examples, and then I will conclude. So we begin with what is mathematical modeling. Now, I've searched the literature on how experts view this idea of mathematical modeling and what do they really, how can they really define what mathematical modeling is about. And my conclusion after looking at various journal articles, papers, books, and so on is that even the experts can't really agree on a very precise definition for mathematical modeling. These are what some of them say, all right? Some say that it is simply a mathematical representation of a physical situation, as simple as that. Well, that can be very wide, right? And there are others who feel that there should be a difference between mathematical modeling and simply application of mathematics. So there are differing views. Some other researchers and math educators feel that understanding, simplifying, and solving some real-life problem is mathematical modeling. It can be as simple as that. So maybe not even solving a real-life problem, but understanding the problem is already part of mathematical modeling. So as we can see, people do have disagreement on how mathematical modeling ought to be defined, but I'm not sure if that's really important. Yanagimoto feels that mathematical modeling has got to do with applying mathematics which is useful to society. See, the word is useful to society. So if you do something in mathematics which is not useful to society, then it is not mathematical modeling. Okay? Peter Galbraith feels that there are two basic approaches to the teaching of mathematical modeling. One is the open approach, and the other one is the structured approach. In his paper, he also gave examples of what is meant by open and what's meant by structured approach. I think we can see from here that there are differing views, and some may feel that it's a very loose kind of definition or will do, but others feel that we need to be a little bit more specific about what we mean by mathematical modeling before we even start talking about teaching of mathematical modeling. But whatever it is, I think we can see that from the all the different views that mathematical modeling should have some connection or something to do with problems in real life. And talking about real life, this is a real life piece of news. I'm not sure if you come across this article in the papers just last Sunday after the first Singapore International Mathematical Competition that was held at one of the schools last week. I think one person in this room has been involved in organizing this particular competition. So I shan't say too much about the competition, but I just want to point out this particular report for the winning team. This is a winning team for the on-site challenge. Now, the theme for the competition is on mathematical modeling. So there were, I think, 57 teams participating in this competition. And for the pre-site challenge, they were given a certain problem. And on-site, when the teams are here, they were given another problem. And this problem has got to do with real life. So it's mathematical modeling. Now, when asked whether this winning teams, they were interviewed by the reporters, and then they were asked whether they enjoyed the competition, and they say yes, they do, maybe because they won the competition. But then the student added, the student said that in school, all we do is pure maths, but maths modeling is about real life. I think he put it very succinctly, that mathematical modeling has to do with something in real life. So while we can't agree on a very precise definition for mathematical modeling, perhaps we can talk a little bit about the processes involved in mathematical modeling before we go on to talk about examples and how best to approach this teaching of mathematical modeling. Now, we usually start with a real-world problem, and we hope to obtain a real-world solution or a solution in the real world. Now, this process is often difficult. That means going from the real-world problem directly to a real-world solution may sometimes be very difficult and even impossible. So in mathematical modeling, we try to then bring the real-world problem into the mathematical world by constructing a mathematical problem out of the real-world problem. All right, and in the formulation of the model, we very often need to simplify things a little bit, make some assumptions, and then formulate some equations, and hopefully we are able to solve the equations. Now, usually in the mathematical world, this part, formulating equations and solving equations, this process is a little bit easier because we have a host of methods of solving equations. All right, and different approaches to solving equations. And then that's not all. In mathematical modeling, we have to remember that we need to be able to interpret the solutions so that we have a real-world solution, because having a mathematical solution is not good enough in mathematical modeling, because we need to eventually solve the problem that we start out with, all right, which is a real-world problem, and we hope to get a real-world solution. So this process of model interpretation is important, and very often we need to collect some data from the real world and then make an assessment of whether this